Okay, so here we had a constant magnetic field that doesn't create any changing flux, doesn't cause any current to flow. Now what happens? Now we open the switch. It had been closed for a long time, now we open it. So what happened to the flux that was over here a second ago? It's gone now. Right? You turn this current off, it turns off this magnet, the magnetic field goes away. So a split second earlier, there was magnetic flux coming out, and what happened? It decreased to zero. Right? There was something there, and it's decreasing to zero. So what direction is the induced current? We're going to have induced current? Yes, because there's a changing flux, right? We had magnetic flux, now it's gone. That's a change. That's going to induce current. The current's going to go in the direction to do what? To try to get it back to where it was, to oppose the change. So it's going to add its own magnetic flux out of the page to try to get it back. It had magnetic flux pointing out of the page a second ago. Now it's decreasing to zero, so it's going to add to it. How does it do that? It has to go counterclockwise to get its flux to come out of the page. So the induced current, I'll put in red here, has to go, what did I say? This way. Okay? Let's do one more. We've got two coils of wire wrapped around an iron core. The one on the left has a battery and a switch. The one on the right just is attached to a resistor. We want to know what direction, just after closing that switch, what direction is the current in the resistor? Let's see. We close this switch. The current is going to go up on this side. So that means it's coming down like that, right? So what direction is the magnetic field in this coil? To the right? Okay. Let me move it down a little bit. If this is the coil, the side closest to you has the current coming down. The side on the other side of the board has the current going up. So you can wrap your hand around it this way. The magnetic field inside the coil goes like this. Or you can run your thumb in the direction of the current in the wire. And inside, my fingers point that way. So the magnetic field points to the right. So the coil on the right had no magnetic flux a second ago. Now it has a magnetic flux, right? This iron core helps it move through here. Now there's a magnetic field created by the other wire. So it had none. Now it has something. So what direction is that current going to go? Current's going to try to create its magnetic field pointing in the other direction. So it's going to come up this side. You see that? And down the back. So it creates its magnetic field in the opposite direction. So it'll be going to the right. After the switch is closed for a long time, right? No current in that secondary coil because nothing's changing. There has to be a change in flux to get that induced EMF, to get that current to flow. Just after opening the switch is closed for a long time. We open it. It's going to go the other way, right? Because now the field is reducing to zero. Those blue lines to the right are getting smaller and smaller and smaller. And so the circuit on the right tries to create a current to add to it. So the current would have to go in the opposite direction I have drawn there. And then after it's open for a long time, I equals 0 again, right? No change, no induced current in the other loop. Okay?